Hello friends, welcome back to our channel. It's Godfrey and I'm from GovCard. And here we are here to talk about some of the key changes to do as we are going to run the analysis. Yeah. So in the what will determine our values in the analysis? What will determine the number of bars to use? What will determine the spacing of the bars to use? And what will determine everything in the uh, what will determine everything in the plotter structure and the details we are going to use. So today we are going to run the settings tab and we can find out what are the key steps to do before running our analysis. Yeah. So let's begin. We have our settings tab here on the G icon. When you reach there, we see settings center, and we shall click in it such that it can display the settings in the uh, our Plotter environment. Our Plotter structure environment will bring us the view and save. Shows how it will save and display of the our icons. Axis indicator color shows us the insertion line color, everything. Actually, I like this one to keep it at default. The width step 1000 meters millimeters. Object snap, all this should be in place such that we can be able to see the intersection of points, the column insertion points, each and everything as you can see here. The graphics performance, we can leave it as that uh, default. The plotter details environment, it will also shows us our how will the plotter details look like, and we can be able to change them from this center. Yeah. Then project preferences, nothing to change many here, but we can maybe add the title uh, and put the client's name, the project title, number, date, address, and the consultant maybe can be able to put them here. The statistics can change them from this tab. The notes we can also obtain them from the notes. We can maybe write them on this panel. Yeah. So the units and format, we can show us the force. It will be in kilonewtons, the displacement in meters, the length in meters, mass, and these are the units of measurement. As you can see here, they are always indicated. Yeah, the labels, how the labels will look like. Is it a circular column? Is it a rectangular column? Is it a slab? What will it be? It will be shown in the settings here. Template shows you how some templates look like, but there's nothing to change here because as you can see, this one will show this is uh, story 1, but column 5. As you can see, we can keep this default. The code we have in the beginning of our document, we chose Eurocode, and this will be the Eurocode up to the end. Lateral loading, wind loads, we define them when we're doing the loads, and earthquake loads as lateral from the y direction. Lateral drifting, we can see if the structure will move sideways. That's where we include the column which are braced and also the walls to be braced. If I can show you how the braces look like, let me search. As we have our pen here, and let's say we have uh, a column here and a column here. The braces maybe can be made like this, these ones can prevent the structure from moving sideways. As you can see, there are no horizontal movements. Yeah. So uh, as you can see, we the most things to deal with here are the column, beam, slabs, foundations, etc. Here. For the columns, if we go in the design, you can see the column minimum steel ratio, it should be 0, and the column limit steel ratio should be 0. Yeah. If we choose 0, the code it's for the code settings, and all these ones can be left default. Yeah. Then we have the minimum steel percentages, which are here, and then the parameters, we can check them from here, but most likely these settings are they are left uh, default. In the rebars is where we have to change much. As we said, I usually like the bar size minimization method because the software will iterate from the minimum bar. If it fails, it continues to the bar of a better size. If it fails, it continues to a bar of a higher size. For bar spacing maximization method, it means that it will start with a higher spacing of the bars. If it fails, it goes to a lower spacing. If it fails, it goes to a lower spacing. And this one is the fixed bar layout method where you have to fix. Yeah. The column containment, it shows how the columns, if it will have the shear links, how will they be? If our breadth to height ratio is less than 8, what shall we use? We can use maybe a single link, and if you want, according to your preference, you can use any of these. If our B to H is maybe greater than 1.8, what shall we use according to our preferences? It is better to know that what shall be put in this setting. It will actually go to what you do. It's actually what the software will do. So we have to be careful as we are checking these containments. Yeah. Then we have the wall containment. How many are they? For a short wall, what can we use? And for a long wall, what can we use? The longitudinal bars, it shows us the column bar size. The minimum, I chose 12. You can also choose 16. You can also choose any. And the maximum, we can use 12. We can use even 16. Yeah. So, uh, the maximum, let's use maybe 20. For the wall bar size, let's limit our diameter to H8, then the maximum, let it be to H12. As you can see, even here, the minimum column steel bar spacing, it is 25. So, at any step, there should no be spacing which is less than 25 millimeters, and the maximum should be 200 millimeters. The maximum web steel bar spacing also 200 millimeters. Then the step means the software will iterate for 25 millimeters. If it fails, it goes to maybe 50. If it fails, go to 75. That's the step they are meaning. Here it is 5. Maybe you can even put 25, like how I was saying, and it can be left like that. Yeah. So, and then the concrete cover to use, we have exposure conditions due to fire resistance and humidity, environmental conditions that will enable us give us the concrete cover. But in this case, if we do not choose the concrete cover, the software will only give us the 25 millimeters. Yeah. If we choose 0, uh, the software will make for us 25 millimeters. We go to the links, the shear connectors, the shear resistors, and I specified my minimum to be H8. Yeah. And the spacing, the minimum should be 100, the maximum 300, and the step being 50 millimeters. And then the wall horizontal bar maximum spacing to be at 300 millimeters. Yeah. Then the link properties, create support region for the links. You can check this maybe. and provide links through beam depth. You can also check this according to your preferences. For the mesh theme, you can leave that one uh, default. Then in the detailing, we have uh, uh, the general. How will the details be? At the river control, the bob control, the bob just simply means the hook. How will it look like? Is it going up to the top here, or is it left before the at the top of the column? It's up to us to use any of these. As you can see, I chose this. And then for the walls, how will it be? Is it the bars are out? Are they the distribution bars outside the links? Uh, they are called the tension bars. What about if the crank is in the head zone? Any of this we can check according to our preferences. Then the single link type shows how the link will be. Is it at 135 degrees south or at some time we have the 90? It is up to us to choose what will be helpful for us. Then the elevation shows us how the elevations will look like. The river spacing 100 millimeters. If you want, you can use maybe a corner bar, but which I don't like to me. And the shear wall longitudinal bar extension, we can use this or we can use any of these. Yeah. So the display section, it shows the column insertion axis. We can maybe display this, and the dimension column section, we can also insert this. As you can see, if you want all this to be in your details, you have to make sure you check all this. Then the schedules gives us the bar bending schedule, the quantity tables. We have to group similar columns, center column labels and text, draw separator lines between label text. As you can see, everything is shown everywhere. Yeah, draw outline for the change in column size. We can maybe draw for this. Show the link details. We can also show all this. The link count, we can also show per section or per flow. Let's choose per section. And then we go, after that, we can go to the beams. What was in the beams, it is the same thing. What was in the columns is what is in the same as beams. What we do, the design, look at this, we can change any. Then the field bar selection, the method. We see I use the river max, the river spacing optimization method, but you can choose the river diameter minimization method, such that it begins with the smaller bars. Remember, when we are designing, the most thing is to reduce cost, and then uh, from the shop, the bars of a less diameter are usually cheap than the bars of a higher diameter. Yeah, the design, it you look for the pattern number 3. You can also choose number 2 and see how the ribbons change in the section. Actually, I like standard pattern number 3. Yeah. Then use at least 2 bars in the second layer. If you have 2 layers, we can use 2, uh, or use the same bars in the first and the second layers. You can use any of these. Usage of support, we can leave this default. For the bent up bars, we don't need any bent up bars, whether in the floor beams or the ribbed beams or the foundation beam. Yeah. Then the links, as we said, how are the links going to be? Yeah. Type closed and rib links, how do they be? The standard, our links should be of this kind. Yeah. We shouldn't have the open links. No. We shouldn't have the closed links. What we should have should be the standard links. The extension should be 500 millimeters. The curtailment, the field bars shows how the bars will be arranged. I usually like to match the similar bottom span bars and also the top span bars. And I love my bars outside the support. Uh, Field bars too shows us the hook control, and it is we can be able to change according to our like, yeah. The bob control also here, where if we use this, as you can see here, it is moving down. We do this, you can see how it is moving, and I usually like this one. Yeah. Then the detail drawing general, actually we don't need to change much of the things here. Yeah. As you can see, what you will put here is what will be shown in your detail drawing. For the sections, we can make sections for different beams. If they are same beams, there are no sections that should be made here. But if we click all beams, if I click all beams at everything, it will show us the sections at those beams. Yeah. So I have to click for maybe the different beams, and then the steel bars and links shows us what will be shown in the details. Sidebars shows us what will be shown. Dimensioning, what do you want to be in? What do you want to be in your dimensioning? Are they the toppings? Are they the beam widths? What do you want? Yeah. Then the detailing, you can leave it at default. The ribbed bars, the foundation beam, and detailed for beam. Uh, then after that, we go to the slabs, and then we can look in design. This one can be left default. The rebars shows the slab pattern should be straight bars, not bent up bars. The minimum bar size should be a H10 bar, and then the spacing, the minimum should be 100 and the maximum should be 250. If we want, we can maybe change to 300 millimeters. Yeah. Then the step 25 millimeters, the steel barring step 50 millimeters, and then the other things as we want in our drawing. The appearance should show all these things in the appearance. Then for the foundation, what we did is what will be shown here. We have the soil unit weight, we have the allowable stress of the soil, and the soil vertical subgrade coefficient. All of this we can be able to change at this point. Yeah. Then uh, for the stairs, usually uh, detail stairs in the detailing, in the portal detail. So there is nothing much to change here. As you can see, they are showing us the concrete cover, the bottom rebar minimum bob length, the bobs means the hooks, and then the minimum bob length for the top rebar, as you can see here. Then all others are still settings. If we had done the steel number, we would have changed the steel settings. But for now, we are going to first leave the steel settings and concentrate on the reinforced concrete structures. Before you leave out here, we need to talk about the rebars and go to general. Then general, we leave that one as default. And then the rebars, we have to come and check show rebar layer information. If we don't show it, it won't be shown in our diagram. Yeah. So after you have marked this, you can change many of what you need here. After doing that, after you have made these changes, what you have to do is to come and press OK, and it will give us a warning. Uh, Actually, it has not given us but it gave us, and it moved away very fast. If I go to my settings and press OK, it usually gives us a warning that the rebar information has changed. Yeah, do you want to update? Yeah, if we don't need update, we press no. If we want to update, we press yes. Now from that point, it's where we come to drawing the slab strips, which will show us the number of bars we need to use in the our drawing. Yeah. So the slab strips are usually found in the modeling and here, and it will give us the stream here that shows us the one in the x direction and the y direction. So I only draw one in the x direction. Those ones just show the strips which are parallel to the x direction, and it is from beam to beam. This one shows it is from a slab to a slab, and this one is a cantilever. Yeah. So I will use beam to beam in the x direction, parallel to x. Click on this point, press Ctrl such that it can be horizontal, and I press it, and uh, uh, my bars will show here is a 19H10 at a spacing of 250 millimeters, and it is a top at the top match, and also here 19. We also have here at this point where we have 24H10. This is because what is bringing this uh, this ones are 24 at the bottom match. Yeah, these are 24 at the what? At the bottom match, as you can see. Bottom. Yeah. So if let's say you want to draw in the y-axis, just press in the y, beam to beam from here, press Ctrl so that it is purely vertical, and press there. As you can see, this one shows us the 19H10 top, and here 19 top. So this bar will continue from here up to this point, and also have our 24 as the uh, this one is top, and this one is top also, and also have this one at the bottom top. Yeah. So as you can see, analysis needs some settings to do before you run the analysis. Also, if you want to have the strips in the in the ribbed beams, now they are no longer the analytical strips, but they are all called the FE strips. Yeah, they are called the FE strips. So we have to go to general, change this one into an FE strip. From where to where? From beam to beam. Check here and press Ctrl, and then press here, and our slab strip will be formed. One of the things, if you don't draw a slab strip here, the you can't see the number of bars we need in the details here. So strips are also very important before detailing the slabs here. So this one marks the end of our lesson today. If you have been able to make it to the end of our training for this day, thank you very much. And if it has been helpful, please don't fail to share, subscribe, to share, like, and comment our video. And don't always forget to tell me where you are watching from. Yeah. Uh, for the new viewers, I kindly request you to subscribe so that we can take this channel to a very greater height. For Aspera Adastra, I remain Gavcard from Godfrey. Godfrey from Gavcard Engineering Solutions. Bye. See you in our next video.